Imagine a man who saw the universe not as numbers on a page, but as a living, breathing mystery. A man who could make the invisible dance before your eyes. Richard Feynman risked his life to unlock the secrets of the cosmos, yet he spent every single day asking one simple question: why? What if I told you that the world as you know it is only a fraction of what truly exists, and that one mind, one curiosity, could show you the rest? In the next few minutes, you will see why Feynman wasn't just a scientist, he was the heartbeat of the universe itself. Richard Feynman was not a man who followed the rules of society or science blindly. From an early age, he questioned everything. While other children accepted what adults said as absolute truth, Feynman wanted to see it for himself. He would take radios apart just to understand how they worked, not to fix them, not to show off, but simply because he was driven by curiosity. That curiosity was not casual, it was relentless, almost unbearable. It pushed him to explore paths that others thought unnecessary or even impossible. In school, Feynman did not simply memorize equations or follow textbooks. He challenged teachers, not out of arrogance, but out of a deep desire to know the essence of things. If someone told him something was impossible, he didn't accept it, he experimented. He tested it, dissected it, and looked at it from every angle. This approach frustrated some people, but it defined him. It was this refusal to accept easy answers that would later allow him to make breakthroughs in physics that changed the way we understand the universe. Feynman believed that curiosity was more important than authority. He saw that too many people allowed titles and positions to dictate what was true, and he rejected that. To him, truth was not decided by consensus. It was discovered through observation, experimentation, and a willingness to question everything, including oneself. Even when dealing with the most respected scientists of his time, Feynman would not be intimidated. He treated ideas as challenges, not hierarchies. This way of thinking led him to explore quantum mechanics in ways that no one else had dared. He visualized particles and interactions in a language of his own making. He developed Feynman diagrams, a revolutionary method of illustrating the complex interactions of subatomic particles. While others relied on complicated mathematics alone, Feynman combined imagination with rigorous logic. He literally drew the invisible to make sense of the universe. Without his curiosity, these diagrams might never have existed, and the field of quantum electrodynamics would have taken decades longer to advance. Curiosity drove Feynman in every aspect of life, not just science. He learned languages, played musical instruments, explored art, and studied the human brain, all because he wanted to understand the world in every dimension. He did not see curiosity as optional, it was necessary. He often said that if you were not interested in discovering something for its own sake, then you were missing the point of life itself. Even in moments of moral conflict, curiosity guided him. Working on the Manhattan Project, he was deeply aware of the consequences of his work. Yet, he did not allow fear or societal pressure to stop him from questioning the physics, the ethics, and the possibilities. He observed, he experimented, and he reflected, knowing that understanding was more powerful than blind obedience. Feynman's curiosity was contagious. When he lectured, he did not just explain physics, he invited his students to see, feel, and question the world as he did. He wanted others to experience that thrill of discovery. He showed that curiosity could be playful, adventurous, and deeply human. It was not limited to scientists or geniuses, it was a tool anyone could use to explore reality. In the end, Feynman's life proves that curiosity is not a luxury, it is a necessity. It allows us to challenge conformity, see beyond accepted truths, and push the boundaries of knowledge. It reminds us that the universe is not just a set of equations, but a mystery waiting for those bold enough to ask why. Curiosity over conformity was not just a principle for Feynman, it was a way of living, a way of thinking, and ultimately a way of changing the world. For Richard Feynman, science was never about memorizing formulas or repeating what was written in textbooks. He believed that learning should be an act of seeing, of understanding the world in its raw, unfiltered form. To him, the equations on a page were not just symbols, they were tools to reveal reality, to explain why the universe behaves the way it does. He refused to let learning become a mechanical exercise because knowledge without understanding in his eyes was meaningless. Feynman had a unique ability to take the most complex concepts and make them tangible. He could explain quantum mechanics not with pages of abstract equations alone, but with stories, analogies, and illustrations that allowed anyone to picture the invisible. He made particles dance, light waves sing, and forces interact in ways that felt almost alive. His lectures were not performances, They were invitations. He invited his students and audiences to see the world as he did, full of wonder, full of questions, and full of beauty. He despised rote learning. When students would recite memorized solutions without truly understanding them, Feynman would challenge them to think for themselves. He would ask a question that no textbook had the answer to and force them to reason through it. He wanted them to see, not just know. For Feynman, true education was about cultivating insight, the kind that makes you stop and marvel at how the world works, rather than just pass exams or recite rules. This philosophy transformed the way he taught physics. His lectures at Caltech became legendary because they were not about delivering information, they were about opening eyes. Feynman would often begin with a question, something seemingly simple, and then guide his audience through an exploration that revealed the deep structure of reality. He showed that learning was an active process, a dialogue between curiosity and observation, between mind and universe. Feynman's approach was radically different from most traditional teaching methods. Instead of focusing on memorization, he emphasized problem solving and experimentation. He believed that if you truly understood something, you could derive it yourself, explain it in your own words, and even apply it in ways no one had imagined before. Knowledge, in his eyes, was a living thing. It had to be used, tested, and questioned constantly. Even outside the classroom, Feynman applied this philosophy to every area of life. He would experiment with safe cracking, play the bongo drums, or explore art and biology, not as hobbies to fill time, but as exercises in understanding, observation, and engagement. He saw the world itself as the ultimate textbook, and curiosity as the method of learning. Nothing was too small or too ordinary to escape his attention. He saw lessons in everything from nature to human behavior. Feynman also believed that this approach to science built character. Understanding the world requires patience, creativity, and humility. When you observe, you often confront the limits of your knowledge, and that confrontation can be uncomfortable. Feynman taught that this discomfort was essential. It was through wrestling with confusion, through experimenting and failing, that one truly learned. Memorizing solutions would never give that depth of understanding, and for Feynman, depth was everything. His famous Feynman technique captures this philosophy perfectly. He would take a concept, try to explain it simply as if teaching someone else, and in the process uncover gaps in his own understanding. This method forces clarity and insight, not rote repetition. It is a practice that turns abstract knowledge into lived understanding. It transforms learning from a passive act into an active, emotional, and intellectual experience. Feynman's insistence on seeing over memorizing was not just about education, it was about life. He believed that the universe is too complex, too beautiful, and too mysterious to be reduced to rules that we simply recite. To experience science, you must engage with it, question it, and feel it. You must allow yourself to be amazed by it. Only then can learning become transformative, not just mechanical. In the end, Feynman's philosophy reminds us that education is not about collecting facts, it is about learning to see. It is about developing the skill to observe deeply, think critically, and wonder endlessly. Science, when approached this way, is not a chore. It is a lens through which the universe reveals itself. Feynman's life teaches us that true understanding comes when you refuse to accept the world passively, when you seek to see it clearly, and when you let curiosity guide your eyes, your mind, and your heart. Richard Feynman was never a man to shy away from the consequences of his actions. He understood that knowledge without responsibility could be dangerous. From the very beginning of his career, he faced situations where curiosity and ethics collided, and he did not back down. He was part of the Manhattan Project, working on the development of the atomic bomb during World War II. It was a project of immense secrecy and immense power. Many would have obeyed orders blindly, but Feynman observed, questioned, and thought deeply about what he was creating. He knew that his work could save lives in the long term, but it could also destroy millions in an instant. That awareness never left him. Even in the most intense environments, he insisted on truth. He did not allow fear, authority, or social pressure to prevent him from understanding the reality of a situation. He asked difficult questions, sometimes making his superiors uncomfortable, but always seeking clarity. He knew that courage in science is not about bold experiments alone. It is about facing the moral, ethical, and practical consequences of what you discover. For Feynman, hiding from the truth was never an option. Years later, this courage became legendary during the investigation of the Challenger disaster. The nation was grieving and the pressure to protect reputations was immense. Feynman, however, refused to be intimidated by politics or authority. He conducted his own experiments using a simple glass of ice water to demonstrate how the O-rings failed in freezing temperatures. That small act of courage spoke louder than complex reports or official statements. It exposed the truth in the clearest way possible and saved countless lives in the future by preventing similar mistakes. Feynman understood that courage in science is intimately tied to honesty. It is not enough to follow formulas or procedures. One must face the facts even when they are uncomfortable or inconvenient. Science is a mirror reflecting the universe as it is, not as we wish it to be. Feynman's life exemplified this principle. He confronted reality head-on, even when it meant challenging colleagues, questioning authority, or facing public scrutiny. This courage was not limited to large-scale projects or life and death scenarios. Feynman carried it into every experiment, every lecture, and every moment of discovery. He was willing to admit when he did not know something, to explore the unknown without pretense, and to take risks in thinking where others would play it safe. He treated failure not as shame, but as a natural and necessary step toward understanding. That required immense bravery. Most people fear mistakes or embarrassment, but Feynman embraced them as teachers. Feynman's courage was also emotional. He faced the weight of his work, the moral implications of scientific advancement, and the disappointment of failure with honesty and integrity. He did not hide behind excuses or authority. He looked directly at the consequences of his discoveries, knowing that understanding without responsibility could lead to disaster. His life teaches that true science demands not only intelligence and creativity, but also moral courage and emotional fortitude. In every story about him, from the Manhattan Project to the Challenger investigation, one theme emerges: Feynman never compromised the pursuit of truth, no matter the cost. He understood that facing consequences, ethical, professional, or personal, is not a burden but a duty. Courage, he demonstrated, is not a dramatic act performed once in a lifetime. It is a continuous commitment to honesty, integrity, and the rigorous pursuit of understanding. Feynman's example is a reminder that knowledge carries responsibility. To observe, experiment, and learn is not enough. One must be willing to face the implications of that knowledge. His courage shows us that the value of discovery lies not only in what we know, but in what we are willing to confront, reveal, and act upon. Science, in Feynman's hands, was never passive. It demanded bravery, accountability, and an unwavering commitment to truth. Through his life, Feynman proves that courage and curiosity are inseparable. You cannot truly explore the universe without being willing to face consequences, question authority, and stand by the truth. That courage is what allowed him to uncover hidden realities, challenge conventional wisdom, and leave a legacy that inspires generations to come. Richard Feynman believed that learning and discovery were not just serious, structured activities. They were adventures, games, and acts of wonder. He approached science with the heart of a child, finding joy in exploration and excitement in every question. To him, play was not a distraction from learning. It was the very essence of it. He showed the world that curiosity combined with imagination can open doors that logic alone cannot. Feynman's approach to life was playful. He famously learned to play the bongo drums not to perform on stage, but to experience rhythm, creativity, and focus in a completely new way. He explored art, drawing and painting with the same curiosity he applied to physics. He even cracked safes at Los Alamos during the Manhattan Project, not to steal secrets, but to test his own understanding of locks, security, and human psychology. Every playful experiment, every eccentric hobby was a method of learning, a way to see the world from new angles. He believed that play encourages thinking without fear. When we play, we experiment without worrying about failure or judgment. Feynman applied this principle to science, encouraging students and colleagues to explore boldly, to make mistakes, and to learn from them. He saw that fear of being wrong often prevents discovery, while curiosity and play open minds to endless possibilities. In his view, the mind is most alive when it is free to wander, to imagine, and to ask, what if? Feynman also showed that inspiration comes from wonder. He was mesmerized by the smallest details of the universe, how a particle moves, how light bends, how nature repeats patterns in ways both simple and astonishing. He could sit for hours observing something ordinary and find extraordinary insights. His wonder was infectious. When he spoke about physics, people didn't just hear formulas, they felt the thrill of discovery, the sense that the universe is full of secrets waiting to be uncovered. This sense of play and wonder shaped his teaching. Feynman refused to make students memorize facts without understanding. Instead, he designed lectures that invited them to explore. to experiment mentally, and to experience joy in the process. He used stories, analogies, and demonstrations that made science feel like a puzzle or a game. Learning in his hands was never a chore, it was an adventure, and anyone willing to follow could participate. Feynman's life reminds us that play is not frivolous. It is a vital tool for creativity and understanding. Many of his scientific breakthroughs came from thinking freely, testing ideas in unconventional ways, and approaching problems with curiosity unbound by rigid methods. By treating discovery like play, he was able to explore paths that others overlooked, to imagine solutions that had never been considered, and to reveal truths that changed the way we see the world. Even in difficult or serious moments, Feynman applied wonder. During the Manhattan Project, even while dealing with the gravity of developing the atomic bomb, he found moments of curiosity and playful observation. Later, during the Challenger investigation, he approached the problem with clear-eyed analysis but also a creative mindset, experimenting with ice water to reveal the truth in the simplest, most direct way. Play and wonder did not distract him, they empowered him to think clearly and act decisively. Feynman's philosophy shows that inspiration is available to everyone, not just scientists or geniuses. The world is full of mysteries waiting for a playful mind. Every child who asks why is practicing the same principle Feynman lived by: exploration through joy. By approaching life with curiosity, creativity, and wonder, we see opportunities to learn in every ordinary moment. In the end, Feynman teaches us that science is not just about knowledge, it is about experience. Play and wonder unlock imagination, reveal hidden truths, and make learning deeply human. By following his example, we see that the universe is not a set of rigid rules, but a playground of discovery, waiting for those willing to ask questions, take risks, and find joy in understanding. Feynman's legacy is proof that curiosity combined with play is the most powerful force for learning, creativity, and inspiration.